the process of reversible processes, right? So now we have different kind of reversible processes, but our main interest here will talk about the isochronic process, which is the isovolumetric process of thermodynamics. So now in isochronic process, we say isochronic process. So in isochronic process, we are simply talking about, first of all, we need to understand what is isochronic process. So when you talk of isochronic process, that has to come into your mind. We are simply talking about where the volume is constant. So when the volume is constant, what does this mean? So now, this simply means is that, so when the volume is constant, there is no change in volume. So since there is no change in volume, how can you prove this? So now here, let's prove why the volume is constant. So now let's talk of this example. So first, before we talk of this example, we all know that we are talking about the reversible process in a flow process. Reversible in a flow process. When I talk of reversible or reversibility in a substance or reversibility process, we're simply talking about, this is the process where the reaction, or rather the process, has to be returned to its initial state. So from after performing the reaction, then it's returned to its initial state. That is reversible. Now, reversible in a non-flow process. So a non-flow process, in thermodynamics, we say a non-flow process, this is the process where there is no mass flow. There is no mass flow due to fixed boundaries. So meaning, what do you have a fixed boundary? We're simply talking about the closed system. So a closed system, as it is a non-flow process, meaning it has a fixed boundaries. There is no flow of mass. So mean a flow of mass in a fixed boundary system is equal